Hey. What we've got here is quick little question here, finishing off section 4 of the textbook I gave you. There's one question there, and then we move on to sampling. But this is such a good question, I didn't want to skip it. We'll talk more about it later again, but here's your first time seeing it. What we're talking about here is mean versus median. Mean versus median. Mean versus median, the whole time. So this is really important when it comes to house prices. Basically, they take the median because there are these ridiculous houses that cost millions and millions of dollars, like $10 million, $20 million, and they bump up the mean. They take up the average really, really high. But sometimes you don't want that. So you go with the median instead. Median's better. So let's see why. Let's prove it. Don't trust me, let's see it. So here's our prizes. Prices, not prizes. Ooh, that would be a nice prize. $520,000. That would be a nice prize. All of these. They're a bit hard to see, so I'm circling them. 4, 5, 6, 7, 8, and 9. So there's a total of 9 of them. And that number 8, wow, 8.4 million. Ooh. So here in Tamworth, we don't get prices like this high. The 8.4 million, I've never seen it. But School Court, oof. Even these other ones are expensive, but maybe they're really nice houses. They're really nice. What's the mean house price in School Court? So mean, we need to plus them all up and divide. So I'm not going to do the working out. I'm just going to put in the calculator. So with the calculator, fraction to start, 520,000 plus 470,000 plus 630,000. So 580, then 3 zeros, 790, 3 zeros, 540, 3 zeros, plus 710, 3 zeros, 8.4 million. What's that? That is 8,400,000. Giant number there. So 8,400, and then another 3. And then 660, 3 zeros. And we're dividing all by 9. Quick check. Did I get it right? First number, 520,000, 470,000, 630,000, 580,000, 790,000, 540,000, 710,000, and then, well, that one's got some extra zeros there because that's not 840,000, that's 8,400,000, and 660,000. So easy to make a mistake there. And divided by 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. So according to this, the mean is 1. We'll do it on the side. We'll have to go on the top. 1. What? 4, 7, 7, 7, 7, 7. So many sevens. To the nearest dollar, so 7, 8. Wow. 1,477,778. And those sevens look like 2s because that little drop there. So let's do that properly. A little hook at the end. I've never noticed it before. Must be the pen tablet. Got to be careful. Anyway, they still look a bit like 2s. That's ridiculous. Why is it so high when most of the numbers were below a million? It's because of that damn 8.4 million. It dragged everything up. Whereas median, if we put them in order, gonna have to do it on down here. That's why we use this space at the bottom of the page. Smallest one, 470. I'm going to be lazy. I'm going to just write K. 470K. That means 1,000. 470K. Then the next one is 520K. 540K. 580K. Have I missed one? 479. 630K. It's dangerous when you don't cross off. 710K, 790K. Yeah, I missed the 660K. Oops. Luckily I can drag it across. 660K, 710K, and then 8. We say 8.4 million. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good, and there were 9. So what's the median? Median's going to be the 5th one. It's going to be 4 above, 4 below. 4 above, 4 below. Basically, there's 9, you halve it, you get 4.5. Round up, it'll be the 5th one. So, 630. What? Look at the difference between the mean and the median there. The mean was all the way up there, but the median's a normal value. What effect does having a single $8.4 million mansion have on the mean? It massively increases it. It significantly raises the mean. What effect does have it on the median? No significant effect. It's just, oh, you can't even see that. It's just a normal value that gets crossed off. So we're going to say no significant effect. So then we asked, why might median might be better than mean? Because the median will tell you where most of the prices are. Most of the prices are. The mean can't do that. Can't always do that. Sometimes it can, but sometimes it can't. So I want you to write that down. We'll come back to this a little bit later. This is about outliers and the way they affect. But I want to finish off this booklet. So I'm going to scroll down in 3, 2, 1. Well, it's not just scroll down. No, I'm not doing any of this. Moving to a different section there. 8.6. This is, for today, surveying and sampling. What we want. We want surveying and sampling. So, got a whole bunch of stuff there to read, blah, 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 blah. But let's skip right to the important stuff. Survey. It gives you information about the whole group without having to actually ask everyone. I used to not like surveys. I used to say, oh, let's just ask everyone. Because I wanted precision. I wanted exactness. But no. So, a survey involves a smaller sample. You don't ask everyone, just because sometimes it costs a lot of time, a lot of money to ask everyone. So, take a sample, but make it a good one. So, accuracy can be affected by the size, whether or not it's representative, so whether the small group looks basically the same as the bigger group, or whether it looks different, or bias. If it's biased, maybe like if you've got a group and it's all males, but the society has actual females in it, yeah, then you can get results which tell you a lot about males, but not about the whole society. Whether or there were any measurement errors, which will lead to outliers, blah, blah, blah. And then there's symmetrical or skewed. So symmetry, if I drew a line down the middle, it looks the same both ways, left or right. But if it's skewed, like you got a peak here, and we say there's a tail going that way, a long tail to the left. Well, here's your peak here, and you got a tail going to the right. It's not symmetrical. Oh, pretty fancy thing here. If the data is symmetrical, then the mean and the median are basically equal, basically. Anyway, let's do some questions. Scrolling down. Interpreting survey results. Oh, I don't want to do examples. Example, 8F. Let's do some. Mariko. Mariko? It's that E in there which is confusing me. Because if it was Mariko, it's a normal Japanese name. But then there's an E in there. It's like Mariko. Is it still Japanese? I am so interested. But let's do some maths. Wants to know the average age of drivers in a city. She could say 10 of her friends or 1,000 randomly selected drivers. What do you think's better? And the answer, of course, is 1,000 randomly selected drivers. Oh my God, why is it better? Because there's 1,000. And that will give you better information than just 10 people. What if you happen to ask 10 people and they don't drive? Well, no one drives. No. Silly. And this is 1,000 randomly selected drivers. Yeah, and all of our friends. Well, we don't know her age, but they might be young. Which one's going to be easier, though? 10 friends. And that's the problem. People do what's easy rather than what's right. So I'm going to scroll down so you can see the next one. Ajit. I don't know whether you pronounce it. Ajit. Ajit looks at a random sample of penguins and notes that of the 50 he sees, 20 of them have spots on their back. So he sees 50 penguins. Guys, he loves his penguins. I'm going to go with he. It could be a she. Oh, no. It says he. That's silly me. Of the 50 he sees, 20 of them have spots. So random sample of penguins. Let's hope he's a biologist. Otherwise, well, anyway, maybe he just likes penguins. What proportion has spots? 20 out of 50. Which, as a fraction, is 2/5, 40%, whatever. If there are 5,000 penguins in a region, how many would have spots? So logically, if the sample is accurate, then 2/5 of 5,000 will also have spots. So 1/5 of 1,000, we could just do 2/5. Like the answer is 2,000. 2/5 of, because 1/5 of 5,000 is 1,000. Notice how I became a times there. If there are 500 penguins, how many would not have spots? So not have spots is going to be the 3/5 is our assumption. Either they got spots or they don't. And then we say, what's 3/5 of 500? It's going to be 300. Because 1/5 is 500 and you got 3 of them. Other way you could have done it, you said, 2/5 have spots. So 2/5 of 500 is 200. Take away the 200 and you get the same answer, 300. All right, symmetrical or skewed. I think they used some of the same pictures here. Symmetrical. Definitely skewed for B and C. But what about D? Is that symmetrical or is it skewed? It's symmetrical. It's not realistic. This is exactly symmetrical. Normally, let's pretend this one was up here, and then this one was up here, and this one was down there. I'd still call it symmetrical, even if you had those changes. Still be symmetrical. It doesn't have to be perfect. Statistics is rough. Down. All right. Survey conducted asking people. I'll leave that there. No need to go all the way down. Asking people how many pets they own. You can assume it's a representative sample. How nice of you. Thank you for letting us make that assumption, which you should never ask. You should never. You should always be open to the chance that it's wrong. So, plot the results on histogram. I'm going to do it roughly. Histogram. I know you want to skip it, right? You want to say, it's too much effort. But once you see it on a histogram, you can see whether it's skewed or not. You need to go up to 20. So call that 20. Call that 10, 15, 5. So 0, 20 people. And then 1, 18. Yeah, I know. Bad graph. I know. Then 2 is all the way down to 6. And then 3 down to 4. And 4 down to 2. Wow. That first column. Way too thin. Is it skewed or symmetrical? Well, I don't know. Can't be 100% sure. But I think, maybe, yeah, it might be skewed. Because that ain't symmetrical. I'm coloring in just to make it a bit easier to read. Skewed. All right, so then it gets the tricky ones. And you meant to be doing this in your books. But we're not doing it that way. So how many of them would you expect to have no pets? So 20 of them out of 50. So our fraction of the whole is 20 out of 50 of 1,000. That's going to be 400. I thought it was 40. I was like, wait, that ain't right. 400. So we need some fractions work here. And you can see that. Whoop. Can't see it if it's on the line. Equals giant equals times 400. Of a group of 5,000, how many would you expect 2 or more pets? So 2 or more is these ones. 6, the 4, and the 2 give you 12 out of 50. So 12 out of 50, that gives you your fraction, your proportion of 5,000. 1,200. Taking me a little bit, but there we go. So this is how we do these questions. Why would conducting the survey outside a veterinary clinic cause a bias in the results? So you got the survey, and it's veterinary clinic. What does that bias mean? Bias means that it's no longer a representative sample. It's basically you're asking all these people, if they're at a veterinary clinic, they got pets. What are they doing there if they don't have pets? It's like, hey, what are we going to do today? I don't know. Let's go hang out at the veterinary clinic, even though we don't have pets, just to look at the pets. No, I find that very unlikely. You would get a biased sample. That's all you got to say. It's a biased sample because more people would have pets than normal. More people would have pets than normal. I'm trying to keep it short and to the point. So if you want to find out stuff about overall society, you don't want a biased sample. It needs to be a fair sample, representative sample. Scrolling down. Fred attempts to find a relationship between ages and incomes. He is considering, so the ages and incomes, keywords the ages, incomes. He is considering some questions to put in a survey. So should it be included? What is your current age in years? Hey, that's pretty good to know. Are you rich? Vague. Like someone says, oh, I'm rich. I've got $20. Someone else says, what? $10 million. I'm not rich. You need to have $12 billion to be rich. Are you old? Vague. Like I'm 35. When my little nephews and nieces see me, they probably think I'm an old man. But compared to my grandparents, I'm very young. How much money do you have? What do you mean? That's still too vague. That looks like vague. It's still too vague. What do you mean? Oh, look down here. How much money did you earn in the past year? Good. How much money did you receive today? Bad. What if you receive $0, but your pay comes every 2 weeks? No. Pay is usually irregular. You don't get it the same amount every day. If you lived in a world where everyone got the same amount every day, good question, but not here. And what's your name? I know I skipped it. Do we really need to know it? Nope. People will be worried. They're like, what's your name? And then you're going to ask what's their password. No. So this is stuff about surveys. I'm going to pause for a bit. I'm going to have a look through, see what else I need to help you with before you have a go. All right. So you can have a go at this yourself, but I'm going to keep giving answers because this is tricky. The first time you've seen this, like, you probably never thought about this before. You're in year 8. You're not in year 9, year 10, year 11, year 12. This could be your first time thinking like this. So we've got some survey questions. Unsuitable location and time. When's a bad time to ask? If you're going to survey to find the average number of children in a car, you probably shouldn't ask it at 1 a.m. Because why would you do that? 1 a.m. in a cemetery. Like, that's such a bad... Why are you doing a survey at 1 a.m. in a cemetery? Who's going to be there? Ghosts? You ask the ghosts about their ghost cars? No. Like, that's a bad example. So get creative here. You want to ask people during the day sometime. Probably a range of times, going from anywhere from 7 a.m. through like 9 p.m. There we go. Survey to find how many people are happy with the Prime Minister. Here's an unsuitable time and office is Prime Minister's office. And you ask him. Survey of 1. You're like, and he's happy with it, then it's 100% approval rate. Bad example. Survey to find, or maybe you go to a nursery where there's lots of babies, just babies, and like the babies don't know. Bad survey. Survey to find the proportion of Australians who are vegetarians. Unsuitable time and location. I'm trying to think of some. Oh, yeah. So we go to an animal welfare protest. That's the wrong time to ask. So like, you remember those before COVID, they had these protests, like in the middle of Melbourne, they shut it down. Got people talking. That's what they wanted. If you ask all of those people at the animal welfare protest, I'm pretty sure there's going to be a lot of vegetarians there. But more than usual. I'd be very surprised if they're all meat eaters. That would be a shock. Or even if there's the same amount of meat eaters as normal. Survey to find the average cost of supermarket groceries. What's the bad location and time to conduct the survey? Here's an example for you. You have to think for a bit there. If you go to a remote town where there's only one store, sometimes they charge way too much because there's no competition. There's no one else around, so packet of pasta, not $1, $10. Because where else are they going to go? You're in the only shop for miles around. So sometimes, well, and it's not just, okay, maybe because they're ripping people off, but because, well, it costs a lot of money to ship it out there. So instead of $1, it's like $2 just because of all the shipping. So wrong place to ask. You should ask, you should include places like that, but you should also ask other places. So question 7, have a go at this one. You're going to do a survey in the class, present the results, and talk about it. I'll leave that to you. I'm going to keep going. Factory. All right. Outliers. So again, this is why I'm talking about this. What the hell is an outlier? So we got our weights: 49, 50, 51, 52, 53, 54, 55, 108. What? Outlier. What's going on there? It takes a sample of bars and weighed to check whether they're between 50 and 55. It's like twice as much as the other, so it's probably just 2 bars. 2 bars weighed at once. Somehow they've got 2 on the scale. Or it could just be 1 fat bar, but that's much less likely. So at this point, you see the 108, you can just throw it out and just be like, no, it's 2 bars. Move on. And then once you get rid of it, so you put a fat cross through it, then do we have symmetry? Yeah, you do your histogram. Ooh, I'd still say it's not symmetrical because it peaks here at 53. It's still skewed. But it's only just, I'm going to say, a little bit skewed. It's basically symmetrical, though. Basically symmetrical. We just need some more. We need some 56 and 57 to make it symmetrical. And then you go, we're not doing this one. We haven't talked about IQR. And then if the measurement errors are not removed, which is better, mean or median? Median, 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 median. That's what we talked about at the start. Median's good. When you got weird values, either very small, very big, you want median. All right. Question 9. I like this. This is making you think now. Survey's being conducted. All right. Now this person's super dodgy. They want to make it seem that most adults don't use mathematics. Where and when could they conduct the survey? So you go to somewhere where people definitely are not going to use mathematics. Where is a place where they're not going to use mathematics? I know. Prison. You ask the people in prison, do they need maths? What do they need maths for? They all they need to do is just read the time. Other than that, they just turn up. They don't have to pay for their food. Oh, they do earn a little bit of income. There are prison jobs, and you have to. But not many people have those jobs which earn money. So prison's a good place. In prison, most of them don't use maths. If someone wanted to say that most mathematics use it, where and when would they conduct the survey? Well, you would go to heaps of places, but I'm going to go to an engineering business. So a whole bunch of engineers, they run a business. Oh, they're using maths. Oh, you know they're using maths. Or scientists, or mathematicians, or statisticians, or math teachers. Yeah. All right. How could the survey be conducted to provide less biased results? That's where it's tough. This is one option. You do random phone calls. You just pick numbers at random. You could do it on the street, but sometimes who goes walking around on the street? Maybe some people don't. They just drive to work, drive home. You're going to miss them out. So, going to scroll down. Statistics, you can be creative. All right, so how are we doing for time? 10, 11, 12, 3 to go. This is 2 lessons work, right? Not expected to do this all in one lesson. All right, pausing. And now finally, 10, 11, 12, you can actually have a go at yourself. But now we've explained everything and they're just doing the same thing. So have a go at those. Finish the video here. Hope you enjoyed statistics.